Let's be honest. Have you ever stared at a network diagram that just looks like a massive bowl of spaghetti and felt completely lost? Well, that's what we're going to tackle today. We're going to dive in and see how a simple but really powerful guide can help us make sense of and even build some of the most complex networks out there.
Okay, take a look at this. This is a real-world, large-scale enterprise network. I mean, it's like a sprawling digital city with routers, switches, servers, you name it. And at first glance, it's a lot. It's overwhelming, and frankly, it just looks like pure chaos. This right here, this is our challenge.
I mean, that's the big question, isn't it? If your job was to build this thing from the ground up, or even just to fix one little problem inside of it, that feeling of, where do I even start is totally normal. But you know what? Every great architect needs a blueprint.
And this is ours. See, on the left, you've got that intimidating territory. But on the right, that's our map, the CCNA mind map. This is the blueprint we're going to use to bring order to that chaos. It takes all those core networking concepts and puts them into a logical structure. And we're going to use that structure to build our understanding from the ground up.
Every sturdy building, it starts with a rock-solid foundation. And in the world of networking, that foundation is called network access. This is the ground floor, where we get all the devices physically plugged in and logically sorted out before we can do any of the fancy stuff.
So, the very first brick we're going to lay is the VLAN, which stands for Virtual Local Area Network. Think of it like this. You have one giant office building with all the same network wiring. A VLAN lets you create separate, totally secure floors for different departments. Sales on one, engineering on another, HR on a third. It's all about creating digital organization. And if we look back at our blueprint, you can see exactly where this fits in. Right there, under network access, you've got VLANs and trunking. See? We're not just grabbing ideas out of thin air, we're following a proven, structured plan.
So why do we start here, of all places? Well, because it gives us control right from the get-go. We can segment the network to group devices logically. We can boost security by making sure the HR traffic never mixes with the guest Wi-Fi. And it just makes the whole thing more efficient. It is absolutely the essential first step.
All right, our foundation is poured. All the devices are connected and organized into their own little groups. Now it's time to actually build the internal framework. We've got to teach all these separate groups how to talk to each other across the entire company. And that is what IP connectivity is all about.
To pull this off, we use a routing protocol. And for a big internal network, the go-to choice is almost always OSPF. You can think of OSPF as the building's super smart elevator and hallway system. It just automatically figures out the fastest, most efficient way for data to get from any point A to any point B inside our entire organization.
And this diagram just shows it perfectly in practice. If you look back at our complex network, you see it's not just one giant OSPF blob. It's cleverly broken up into these manageable areas. You see area 11, 12, and 13? They all connect back to a central backbone, which is area 0. This kind of hierarchy is absolutely crucial for keeping a huge network scalable and stable.
Building this out follows a really clear logical sequence. You don't just start clicking around randomly. First, you build out that backbone, area 0. Then you connect all your other areas to it. The protocol itself does the heavy lifting of sharing all the routes, and your last job is just to make sure it's all working the way you expected. Structure, you see, is everything.
Okay, so our internal company network is now a well-oiled machine. Everything's talking to everything else, but it's living in a bubble. The next massive step is to connect our private little world to the outside world, to other companies, to service providers, and of course, to the global internet.
And here we come to a really critical point. The protocol we used inside, OSPF, it's just not built for this job. OSPF is an interior gateway protocol. It's like your building's internal floor plan. To connect to the outside, you need a totally different tool, an exterior gateway protocol. Think of that as the system of highways that connects all the different cities together.
And that protocol is BGP, the Border Gateway Protocol. And I'm not exaggerating when I say this is the protocol that runs the internet. It's the language that all the big service providers and massive networks use to tell each other what parts of the internet they can reach.
Let's look at this diagram here. We've got two huge service providers. So how do they make sure that a customer on provider A can talk to a customer on provider B? You can see it right there in the middle. They use BGP to create that essential link, sharing routing info between their completely separate networks.
Now, this actually creates a new challenge for the service providers. How do they handle thousands of different customers on their shared equipment without everybody's data leaking into everybody else's? Well, the answer is this amazing technology called a VRF, or Virtual Routing and Forwarding. It basically lets one physical router pretend to be multiple separate virtual routers, one for each customer, keeping all their traffic completely private.
And if you look closely at the configuration text on the sides of this diagram, you can actually see the code for these VRFs. Each one of those VRF definition blocks is creating a private, self-contained little routing world for a specific customer. This is the magic that makes modern business VPNs possible. It's just a perfect example of high-level networking in action. All right, we've laid the foundation, we've built the internal structure, and we've connected it all to the outside world. So now, let's just take a step back and really appreciate the whole structure that we've just conceptually built, all by using our blueprint as our guide.
When you boil it all down, it really just comes down to these three core building blocks. First, you've got network access with VLANs to create order locally. Second, you have internal connectivity with OSPF to build a fast, tough corporate network. And third, you use external connectivity with BGP to hook into the global internet. That's the recipe.
And now, when we look back at those original diagrams, they don't seem nearly as chaotic anymore, do they? Now we can actually see the OSPF areas, we can imagine where the VLANs are separating the traffic, and we get how BGP is connecting this whole operation to the rest of the world. It's not chaos at all. It's an elegant system built from logical, fundamental principles.
And that kind of brings us to a final thought. In a world where automation and even AI are starting to write network configurations for us, does understanding this fundamental blueprint, the why behind the what, does that become more or less important for the human architect? It's definitely something to think about.